Before, I was a senior research scientist at NASA, and long before the World Food Prize changed my life, my husband and I lived on a farm in Italy, raising chickens, goats, pigs, and harvesting olives and grapes. But since then, I've learned that farms like ours aren't just plots of land. Our conception of the farm also has to extend upward to satellites orbiting thousands of kilometers in the exosphere. It has to extend outward to the biolabs, scientists, policymakers, and more, and to all of you. Here's why. For most of history, agriculture has been a long, slow process of evolution. Farmers worked independently, tweaking and perfecting their practices over centuries. But that process of slow adaptation won't work anymore. The climate is changing faster than at any point in the last 10,000 years, any point since the farmer planted the first seed. In 2010, I co-founded an organization called AgMIP. It stands for Agricultural Model Intercomparison and Improvement Project. It's a global network of more than 1,000 researchers who build and use crop models, climate models, economic models, and more. We lean on our community of scientists to share information, and we tap into artificial intelligence to help synthesize all sorts of data, remote sensing, crop modeling, climate data. This approach means better, more responsive science, which leads to better, more responsive farms. These advances are only possible with collaboration. Collaboration between scientists, policymakers, and farming groups. It's the only way to get the information in all of our many AgMIP models to farmers all around the world, the people who really need them. In the end, collaboration is how we sow the seeds of progress.
Please join our next seminar in the Catalyst of Change series on January 16th.
Welcome to the Catalyst of Change, Women as Leaders in Science Seminar Series. There is interpretation available in Spanish, French, and Hindi. To access the interpretation, you choose the language of your preference by clicking the translation button at the base of your Zoom screen. This seminar will be recorded and may be available on the CIMMYT webcast. We invite you to follow us in LinkedIn, YouTube, and social media using the hashtag Women in Science for the Catalyst of Change, Women Leaders in Science Seminar Series. On the screen, you will see the QR code that will give you access to Slido for submitting questions and comments to be addressed in the Q&A session. Today, we will be hearing from a very distinguished leader in agricultural research and innovation, Cynthia Rosenzweig, Senior Research Scientist in the NASA Goddard Institute for Space Studies and Columbia Climate School. Right after her presentation, Cynthia Rosenzweig will have a conversation with Vibambi Shimonio, a scientist on crop modeling at the Sustainable Agri-Food Systems Program of CIMMYT. Now, I would like to welcome Brian Govards, Director General of CIMMYT, to officially open the event and welcome our distinguished speaker of today, Cynthia Rosenzweig. Dr. Govards, the floor is yours.
Thank you, Isabel, and good morning, good afternoon, good evening for everybody following online and connecting to this seminar. It is 2024, and let me take the opportunity to still wish you a very happy new year. And here we are back also in 2024 with our exciting webinar series, Catalyst of Change, Women Leaders in Science. At CIMMYT, last year we launched a TED Talk meets Fireside Chat style series on women leaders because we are convinced that we need more women leaders in science organizations like ours. And to achieve that goal of broader representation, gender balance, and diversity, we did not only express it explicitly in our logo, but we also need to give the tools, examples, because you can't be what you can see. We need to provide, therefore, more opportunities to hear from different life journeys, lessons, and insights. We highlight women leaders, leaders in all sorts of capacities, fields, and disciplines, because we believe you can be a leader in your community, in your family, in your organization, in your country, on the globe. Cynthia Rosenzweig is a true catalyst of change and our guest speaker today. She is a senior research scientist at the NASA Goddard Institute for Space Studies that is co-located at the Columbia University Climate School's Center for Climate Systems Research. At NASA GISS, she heads the Climate Impacts Group, whose mission is to investigate the interactions of climate, both variability and change, on systems and sectors important to human well-being, including agriculture, cities, and conservation. You have immediately see how this talk today sits square in our 2030 summit strategy. Rosenzweig, Cynthia, is also the co-founder and member of the executive committee of the Agricultural Model Intercomparison and Improvement Project, an acronym that is more known as the long name ACMIP, a globally integrated transdisciplinary study of climate change and the food system at regional, national, and global scales, including the participation, the coordination, the integration, and the movement to a common goal of over 1,000 leading researchers from developed and developing nations. She has developed new methods of detection and attribution of observed changes in physical and biological systems to the anthropogenic greenhouse gas emissions and pioneered research on the impacts of and adaptation to climate change and climate variability. In 2019, Cynthia was coordinating and lead author of the Food Security Chapter for the Intergovernmental Panel on Climate Change Special Report on Climate Change and Land. She's also the co-director of the Urban Climate Change Research Network and the co-editor of the first as well as the second UCCRN assessment report on climate change and cities. She was the co-chair of the New York City Panel on Climate Change, a body of experts convened by the mayor of that city to advise the city on adaptation for its critical infrastructure. She also co-led the Metropolitan East Coast Regional Assessment of the U.S. National Assessment of the Potential Consequences of Climate Variability and Change, sponsored by the U.S. Global Change Research Program. It is therefore no surprise that in 2022, she well deserved and received therefore the World Food Prize, considered as the Nobel Prize for Food and Agriculture. She is a great leader and a visionary, a strong scientist and a leader that has changed the lives of millions. Not with words, not with empty assumptions and kicking and screaming, but with a calm, passionate determination that's so deeply ingrained in her personality, in her everyday doing the right thing. I am sure that you will enjoy and learn a lot from Cynthia's outstanding leadership experience, as I have done with every single interaction. And I'm also convinced that there's nobody better than Vimbaye to interview her and together set up a nice conversation once we have listened to Cynthia. Therefore, with further introduction, I'd like to give a warm welcome to our distinguished speaker of today. The floor is all yours.
Thank you, Bram, and thank you, Isabel, for the wonderful introduction. And thank you for inviting me to be part of this fantastic seminar series, Catalysts of Change, that CIMMYT is organizing. So I am now going to share my screen and launch in to my talk. Let's make sure this is working. Great. Can you see it?
Yes, we can see it. You just maybe a full presentation. Okay, that's okay.
Yes, good. Yes, good. All right. I think we are all systems go, as we say at NASA. Let me just take one sip of water. Here we go. So in the introduction, in that video, one of the things that I mentioned was the first farmer planting the seed around 10,000 years ago. And that farmer, as you all probably know, is very likely a woman. So women have been part of agriculture, food production, and agriculture production from the beginning, not something added in later. It truly was, I think, very, very likely a creation of women in particular. So today, what I want to do is share now, 10,000 years later, for all of us, a some thoughts on climate change and food, which is the as Bram is saying, really very much my main research area. I'm an agronomist by training on climate change and food, and I'm going to be discussing aha moments and what I call the P's. That's going to be coming at the end in regard to our professional. P stands for, in part, our professional lives as women. And you can see these are all locations around the world where AgMIP is working or has worked. So just a little bit about my personal history. I started out with two farms. One was in Vaglia, Italy, in Tuscany, and you can see the photos there. 1 mile or X kilometers, right? A couple of kilometers up a dirt road, unpaved road. And there is where I fell in love with agriculture and the production of food, and learned to, our neighbors there taught us how to do everything, from raising tomatoes and the olives and the grapes, and as well as raising livestock. So it was a smallholder farming experience. Then when I came back to the United States, I wanted to continue really working on the land. And so then we had another beautiful farm in the New York metropolitan region in the Hudson Valley, 90 miles from New York City. There we raised field corn, sweet corn, and field corn for cattle, sweet corn for the local supermarkets. And again, again, it was a smallholder farm experience. But then I started to study. I decided I wanted to study agriculture more. And I then went to school, I went back and started all over again so that I could study agriculture and food agronomy. And that's where I learned at Rutgers University, which is the land grant university nearest where I was living at the time, raising two children, by the way, there. That's where I learned to do randomized field trials. I worked, and this is where I really became interested in climate crop interactions, working with subterranean clover, a Middle Eastern clover type, to see whether it could be adapted to the more temperate climate in New Jersey. And there what this is showing, the field experiment station, where I also then had my first interaction with NASA, doing maize canopy radiometer measurements of the fields there. So that was the first interaction with NASA, and I subsequently got invited to continue research at the Goddard Institute for Space Studies, which, believe it or not, happens to be in New York City. And there really wasn't anybody there who had a background in agriculture and growing agriculture and all the land aspects. So I was asked to begin to lead the research on how climate change will affect food, because GISS Goddard Institute for Space Studies, the acronym is called GISS, is the home of one of the global climate models that makes the projections. And they did my colleagues who are the climate modelers did the projections of climate change. And Jim Hansen, very well-known climate scientist, was from Iowa. And he asked the question, what will happen to food with these projections of doubled CO2 at the time? And I was the only, at that time, still a graduate student. And that question came filtering down for me. And that's when I said, in order to answer this question, we need to model it. We need to model the climate effects. We need to model the CO2 effects. And there, I then slowly and have been answering, but consistently, persistently, P also stands for persistence, persistently answer that question till today. And so I founded the Climate Impacts Group at GISS. And our group mission, is to conduct cutting edge research on climate change impacts at local scales, where farming actually, we all know, actually takes place. But at the same time, there's many important national effects as well as global scales in the food system and ag and food as well. But of course, anything with agriculture it's not just a intellectual exercise. We have to provide also solutions, and that's what you all do as well. Provide science. So what we do also is we provide science and technology for stakeholder-driven adaptation, mitigation, and implementation solutions. Not going to talk about urban and conservation today, just ag and food. Okay. Let's, sorry. Let's try tea. Here we go. So here's the challenge. Here are the projections of climate change on the whole world. And we look particularly at land areas and land areas that are engaged in agriculture, which are every country in the world, basically. And the left is the simulated change at 1.5 degrees C global warming. That's what the Paris Agreement and the countries of the world agreed in the Paris Agreement in 2015 to aim for that. But they also said, well, but 1.5, but at least by 2. And then on the right is the simulated change at 4 degrees global warming. And what there is now major concern that the countries of the world we're not doing a great job getting to the 1.5 degrees C global warming. Even 2 is going to be very challenging. There may be overshoot in which we go higher and then bring it down. That's now becoming more and more under discussion. So as impact scientists, we need to be looking at all of these, not just 1.5 and 2, but also at the higher levels. Right now, the world is on track to be in between 2 and 4 at around 3. So this is our challenge. So in my research that started out a while ago, I'm going to share just the research trajectory of 4 this was aha moments. This was one of the questions that journalists asked me when I received the World Food Prize. Still so much the thrill and honor of my life. So they said, well, what were the aha moments? So I'm going to share with you what I shared with them. Differential vulnerabilities, creation of AgMIP, climate change faster and worse. And now what's really in our current understanding is that the challenges of climate change involve both mitigating greenhouse gas emissions from food systems as well as adapting. So aha moment number one, differential vulnerabilities. So this is these are, you can see the difference in the technology, right? From the very first modeling study of how climate change would affect crop yields worldwide. Published in the early 90s. The work of it, which also right away from the beginning included scientists from around the world that did their own modeling, because that's one of the secrets of AgMIP, which I'll get to, is that local scientists understand their systems the most. So when we go to the global scale, we still have to be connected right on the ground. And that's why the network and networking together is so important. So really, this is right from the very beginning. On the left-hand column is doubled CO2 without any of the moderating effects, positive effects of CO2 on photosynthesis and water use efficiency. And you can see it's looking very negative. When we add in the CO2 effects, which will be which are definitely real and will be happening, what we see is differential vulnerabilities in which the lower latitude countries are more vulnerable. That's the second column from the left. And that's what we found in the very first study. But also in the very first study, adaptation came in right away, because farmers are, and we know that are not going to just sit there, and they're going to adapt, and we're with scientists going to help them. And so we had adaptation level 1, very simple, changing planting date, kind of things. Adaptation 2, more more intense levels of adaptation that would require some kind of regional adaptation, such as um, uh, 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 establishment of regional irrigation systems. But what we found, that very first aha moment, this work was done in the early 90s, was that the lower latitude countries, as you can see, are more vulnerable. So now as we go through the decades, we see now hundreds of studies later, many of you probably have worked on studies that have looked at how climate change will be impacting, in particular, lower income countries. We find these decades and many studies later, that lower latitude countries are still more vulnerable. And this is one of our studies that we did with funding from UK DFID, now FCDO, with 8 regional teams, 18 countries, about 200 scientists. And what we do here is several things that are illustrated here, just very, very important and good practice, I think, and I'm sure also what you all are doing. One is engagement early, middle, and early, during, and after, and during, all the way through engagement with stakeholders, so we're not just doing things and throwing things over the fence. Another is that we engage with both we have science, climate, they're truly interdisciplinary, really not just but interdisciplinary teams, climate scientists, agronomists, livestock specialists, economists, socioeconomic, communication, stakeholder engagement specialists. We need the whole team to be able to develop and together respond to climate change challenges. And one of the ways we do this in AgMIP is to create protocols for data, models, and scenarios, so that it's not also just any individual study that can do this, but also other studies can use, and other groups and other countries, other regions can use the protocols as well. So that leads to aha moment number 2. What's better than one model? And the answer is dozens of them. So in the beginning, with that first study, I believe there was just one crop model that everyone used, the DISSAT models. That's the family of crop models that I'm actually from, or that's the family. But really, we realized that when we started AgMIP, we said we have to bring all the models together, models and modeling groups. And what I say is that both the models and the modeling groups were mature enough to be able to work together, because before there was a lot of competition among the modeling groups. So this is then we thought, well, maybe there'd be 5. This is the wheat models, some of the early work from the wheat modeling team. We thought that there would maybe be between 5 and 10 wheat models around the world. Well, 27 wheat models came, groups came together to work. And then AgMIP provided the data across a range of different growing conditions. And it also looked at whether there could be um, um, fully calibrated, a lot of data available, or not very much data available, because we know also in a lot of places there's not the great CIMMYT data that all of you provide, but some places that don't have the data. So what we find is, and the X's are the observed, and you can see the mean with the mean lines in these box and arrow diagrams, that the ensemble mean of multiple models predicted yields more accurately than any one model. And this is very similar to what climate modelers have found, and it is true also in agronomic models, in dynamic process crop growth models. And why is this? It's because biases in one model then cancel out biases in another, to be able to bring the full understanding of across the suite of models to bear. And what was very interesting was that this was true under both poorly and well calibrated conditions, so that these challenges of places with poor data, also there was hope that we can utilize the models there. And we can see that this is true also across very different growing conditions, from very um, uh, uh, low water and nutrient conditions in Australia, all the way up to and climate conditions, as well as then in the highest yields coming out of in Northern Europe. So just to say, this idea took hold, and this was the first global workshop in 2010 when AgMIP was founded, and both the global workshops, regional workshops, the commodity work, the different crop workshops, all different workshops. We're just actually in Wageningen right now are hosting this week the newest AgMIP team on machine learning. It's very exciting. And about, I think, 50 people will be either attending that or in person and virtually. So we have a lot of workshops to get everyone together. And this was the 9th global workshop that was just held in New York in June last year. Wait till the end, because you're going to hear about AgMIP 10. Okay, all of this together, this power of working together, is to provide, what's the mission? In NASA, we always have missions and take our mission very seriously. Here to provide science-based agricultural decision-making models and assessments of climate change to achieve local to global food security. So, what's the next aha moment in my research trajectory? So what happened was that all of this was getting going, this kind of work, then the climate started changing even faster and even worse. I'm just going to illustrate this by one slide, which is the announcement that came out last Friday, just 3 or 4 days ago, that the 2023 global surface temperature anomalies, which is how much warmer or cooler each region of the planet was compared to this, is the average from 1951 to 1980. And you can see that last year was the warmest year on record. And this is another major activity of our institute. So we have the climate modelers, and again, this is the same with the impacts. We don't just make the projections, we're deeply involved in the observations of what is happening as well. So it's not just all in the future and eyes glazing over. It's being deeply involved in what is happening now. And this is when Bram mentioned in the introduction that we work on the observations of change in agricultural and production regions as well. So you can see that there's warming. Of course, this is in part related to El Nino. So there's the climate variability going on underlying, but this underlying forcing of the greenhouse gases are basically inexorably warming our planetary climate. So, but we all know from in ag that it's not just this is looking at the mean temperatures really as we go, mean temperature and mean global temperature as we go up, as we go through the years. But we also, of course, know that it's the extreme events. So the extreme events are also increasing not just in temperature, but also other types of extreme events are increasing as well. Here's just some examples in recent times. 2022, this is the severe lack of soil moisture and heat stress on crops that occurred now a couple of years. We're in 2024 now, but that was in the summer of 2022. I'm sure we all remember the terrible extreme monsoon rainfall flooding associated with the flooding in Pakistan in 2022. In 2023, the floods heavily impacted China's grain belt, affecting food security. And here in the United States, the abnormally hot water helped strengthen Hurricane Ian. This is more than 375,000 acres of citrus affected in 2022. So in each one of these are now the attribution of these extreme events have been made to the changing climate as well. Not every single part of it, but now through statistical analyses, we can actually ascertain the contribution of the changing climate to these climate extremes. So this is the challenge of faster and worse. So then from this faster and worse, we then do the crop models again. And here not again, we do them all the time. But here we go from these are the wheat yields and the maize yield projections. This is with 12 global gridded crop models, 5 global climate models, and this is with the highest trajectory of greenhouse gases. We're going through the years up to 2099, and we're seeing again differential. They vary by region, by commodity, and we're coming up to 2099. But guess what? If you remember what I showed you in the very first study, these results are not that different. Basically the same, that we see differential vulnerability by region. See the mid and higher latitudes certainly with wheat are more positive. Maize is very negative, really negative everywhere, certainly on the maize yields. And many lower income countries are still projected to be vulnerable. This is without adaptation. Then, of course, what we do and what we're all doing is we can't just sit there, right? And farmers are not going to sit there. We need to adapt, and we work on that as well. So let me get out of this and go to the next slide. Here's another thing that's been happening lately on this faster and worse side, on the CO2 side. So what this is showing, the work, very important work, that climate change alone decreases calories. The CO2 effects on the photosynthesis and the water use efficiency that restores calories. That's That's what we see on the right. But very importantly, decreases nutritional content. This is and this has been shown to decrease iron content, zinc content, very importantly, both the micronutrient side and the nutrient side and the macronutrient protein side. So we now on our AgMIP teams, remember I was talking about how we create the AgMIP teams. We bring nutrition experts in with us, and we are developing the models to because we need to project not just only the climate effects, but this, and not just the positive CO2 effects, but there's negative CO2 effects on the nutrition. Okay. Aha moment number 4. Hey, wait a minute. First of all, it's not just agriculture, it's the whole food system. And it's not just impacts and need for impacts for adaptation and developing resilience to the impacts, but it's also that the food system is a major contributor to climate change as well. And here we have not just the production, right? Here's what we've spent so much working on, focusing on production, very, very important. But there's everything else, pre-production, the land use, of course, starting with the land use, and the pre-production, post-production, diets and consumption, very, very important, as well as waste disposal, food loss and waste. All of these things contribute greenhouse gas emissions, as well as being vulnerable. So what we now work with FAO, AgMIP works with FAO to measure country by country the ways that each country's food system contributes. And when you add all of that up, it's about 1/3 of all human caused greenhouse gas emissions. So as people working in agriculture and food, we have to now be working on solutions. Both, we can't forget the impacts and resilience, especially with what's going on with those temperature rises. But at the same time, we need to be working to reduce greenhouse gas emissions. So here's my last slide. Here are the P's that I mentioned in the beginning. So as I look back at my research trajectory and pathway, which I just went over, some of the major moments of learning, and that's why it's so fantastic to be a research scientist, because we get an opportunity to always be learning. But how is it that we do it? How is it? So this is just some things that from my experience sharing. So one is a focus on the actual products, proposals and projects and posters and presentations and publications, all those P's, and a steady stream of them. That's why this persistence is coming up, but is very important. A second P is professional organizations. I'm really, when I was one of the founders of Women in Agronomy at the American Society of Agronomy, um, and um, I'm choosing a professional society, going every year, so that you build those relationships, those hookups, I call them, and organize. So first put posters in, then do presentations, then organize sessions, then get on the committees. All of that. There's just tremendous, wonderful vehicles for building research and building careers. Then we have the public relations. This is what all the social media, but even beyond, there's all that we're so attuned to now, that our work, we have to spread the word, and the public relations, both on the social media side, but then I think also just really sharing in a very positive way, um, with all different groups, what it is that we do and the findings. So that's another P part of what we do. And then the final one, as I said, is persistence. Never give up. It's challenging. It's not that easy, but if we just keep going on all these P's, we can be on, any one of us can be on our pathway to a successful career. So with that, thank you so much. Oh, here's the women in agronomy. Look, there aren't that many. We need more women. Please join us so we can build AgMIP together. So that's for protocols, up-to-date events and news, and to join AgMIP, please visit agmip.org. And finally, I'm ending with a major announcement that AgMIP 10 is going to be held at CIMMYT in Texcoco at the headquarters of CIMMYT in spring of 2025. So thanks so much to Bram and all of you for hosting us, for hosting AgMIP 10. And we look forward to working with you to make that a fantastic next AgMIP 10. It's very exciting. It's 10 plus years, but 10 global workshops of AgMIP. So with that, thank you, and look forward to questions, discussions, sharing of experiences. Thank you.
Thank you so much, Cynthia, and hello, everyone. And thank you for that announcement. I think for me, who's been trying, or rather not wanting to be part of AgMIP, I think I'm going to now definitely line up and sign up to be one of the AgMIP members. So my name is Vembai Chimonyo. I'm a crop modeler based in Zimbabwe and a member of CIMMYT's Women in Crop Science group. Being a woman in science can be very taxing sometimes, and it comes with a lot of unique experiences. And in examining one of Cynthia's most cited article, Climate Change 2014 synthesis report that has more than 10,000 citations, I noticed that there are not so many female co-authors. And when I counted them, they were less than 25%. This actually resonates with my own experience, having authored several works where I too am probably a sole author, a sole female contributor to these articles. And I see that you have led but supported other women in other articles that you've written. And for me, I think that's quite important. I think also one thing that made me want to say I really want to have a conversation with Cynthia is that she's the co-founder of AgMIP. And her experience literally dwarfs my own experience in science and agriculture. And I love the P's, the persistence, providing solutions, constantly engaging, networking. I haven't said any P's, but definitely contributed to different P's. So for me, Cynthia, knowing that you spoke a lot about networking, those professional organizations that you spoke about, but you've also done a lot of mentoring. How do you approach mentorship and the need to create these networks for the next generation of women in science? What are those critical steps to empower and support young women pursuing a career in STEM?
Yes, thank you. It's so important. I think we have to be deliberate about it.
Mm-hmm.
We can't just say, oh, this is going to happen naturally. It's not. And it hasn't over the years. I mean, it's much, much, much better than it was when I founded that Women in Agronomy with 7 people, and there were 7 other women in hundreds, among hundreds. And I don't know if I can share this, but maybe I will. That was actually in the gender-based bathroom where we actually said, wait a minute, there's so few of us, we've got to do something. So
that is so inspiring.
That was another aha moment, actually. I should add that. But it's like, you know what, we've got to be deliberate about it. And I really want to appeal to you, Vimbai, and to all the women on this call. We must do this together. We've got to and we have to do deliberate and specific things. It can't just be hand waving. So for example, so we now at AgMIP 10 AgMIP global workshops, we need to do this at all of the workshops. We need to, always like who the women who are speaking and, speaking at the beginning, not just like, the token ones later on. So we now have often, we just have, we have all women panels. That's good, right? How many times have we, sat through many, just sort of all singular based. So,
Yeah.
gender panels. So that, and then, but then we have women in agronomy women in AgMIT meetings at them. So let's work together for the next AgMIT 10. We have special lunches when we all get together and really share experiences, share ideas of what we can do. You mentioned the papers also. I think we have to be deliberate now, making sure that we are including, and you know what else? It's not just women, it's early career
Yes.
as well. I think that there's a really, we're on a trajectory of recognition of how important it is to nurture and mentor early career researchers, whatever gender, and of all genders. And that's also what we need to do. I think we've started, but we need to do that just from now on even more. So it's the papers, absolutely. And so before we get to the papers, we have the proposals. That's why I have the P's, because you don't
Yes.
get to write the papers unless you're on the proposal.
Yes. Yeah.
We've including all genders and early career on the proposals as
Mhm.
well. And then you get on this spiral of getting all the way up to the papers, because that's how it really happens.
Okay. So you mentioned a lot about gender and how you being a woman, you were purposeful in your career, and that has led you to where you are right now. So my question to you now is, how did you navigate that intersectionality of gender and other aspects of your own identity in the scientific community?
Yes. So I think it's very important it's very challenging for often, I think, for people who want to have families and who uh so and to that it's a kind of almost a cliche now, the work-life balance.
Yes.
But I truly believe that it's absolutely essential that everybody has that, if they want it. Not everybody wants it, but if you
Yeah,
want it, it's
true.
very challenging, especially when the kids get sick. That's the hardest.
Yes.
You have your day all planned, right?
Yeah.
And then one
Yeah.
of the kids comes down with a fever. And you have to, it all kind of like gets blown up, right? Your whole day gets blown up. But that's why this persistence is so important. That
Mhm.
it's really, we can do it because we're in this for the long haul. We're going to persist. So if the kids, get the flu or, and can't go to school for a while, or they get something, then we can then just keep going. And now it's actually also a little bit easier because of what we learned during COVID about how we can all work together on Zoom now. So
Yeah.
things are actually a little bit better, I think, but
Yeah.
it has to be balanced and shared. But I just very much believe, because one informs the other, so that if people want families, we must support that.
Okay. One thing that you've mentioned is about the adaptability that we should have when we are pursuing our careers. And one thing that I've noticed, and one thing everyone is definitely akin to, is that science is constantly evolving. and also becoming something else than what we set out, right? And also perceptions are changing. I think that's something that we can definitely say, that even our own ways of thinking, even your aha moments as they became, some of those perceptions were either validated or further solidified. You mentioned in your video, the one that was showed earlier on, that we cannot focus on research that then contributes to slow adaptation. There's no time for slow adaptation. So what emerging trends or innovations in the field of modeling excite you the most? And how do you think they will impact the future of environmental science?
Yes. Okay, so, you know, as you can tell, I'm a very big fan of models because they are integrators of processes and people. And, you know, otherwise, you know, again, when we're thinking about speed and change. So, you know, the CG system is so, you know, world, and Norman Borlaug, of course, came from the CG system. And Simmet, I believe, right? His home, you know, his home institution, organization. The thing is that, and field trials are such an important part of the breeding programs. But what we from the modeling side would like to do, and this, I'd like to propose this, and get your all reactions to it. I think we need to bring together with the modelers even more than we are. I mean, there's now, this is, you know, and AgMap's now not the only network doing this, and CG is doing great work on this. But you see, because we have to adapt so quickly now with this rapidly changing climate, the field trials take a long time. So what we need to do is work together. So we have dynamite models, so we can fast track, so we can do a lot of testing of the adaptation. And we always look at portfolios. You can look at separate adaptations and then them combined, right? And basically do fast tracking for which of the adaptations or breeding potentials that we need for responding to the climate. And then it's like a jump starting the field trials, and then the field trials, and then the community farmer led by trials. So that's what I would say. And that's what we're trying to do. Let me share. I didn't put in a slide on this because I want to get to questions and further questions if there are. We're working with a wonderful project you might have heard of, called Vision for Adapted Crops and Soils, and it's focused in Africa, VAX.
Yes.
And so I'm working with Lindiwe Zimbanda, the chair of the CG board, and also the U.S. State Department, FAO, and the African Union. And this project is bringing together three main groups. Will be expanding to other interdisciplines and other groups and experts, but it's bringing together the breeders, the nutrition scientists, and the climate crop modelers. That's us, AgMap, together. And it's like, that's what we have to do now. We've got to get much deeper into how can the breeding trials and the modelers work together, so we have the data for the models right from the beginning, because this is on indigenous crops. But here's the final thing on this, which is the special thing about VAX. It's for the indigenous crops. It's across the whole food basket. And in last year, AgMap made 25 new crop models for the crops that had never been made. So this is the kind of rapid evolving and working together that we need to do.
Yes. No, thank you so much for that, Cynthia. I had more questions, but time is not on our side. I give the floor back to Inasa and Isabella.
Thank you, Vimbai. It was wonderful to have a conversation with you.
Thank you.
Thank you so much for this very interesting conversation that you have. Thank you, Bimbayi, for Shimonio for this interview. We appreciate now we would like to open the floor for questions from the audience. We invite you to raise your hand, to turn on your camera and unmute yourself if you would like to ask a question or comment, or you can submit it via Slido. Right now, we have a few questions in Slido. So I'm going to read the first one. It says, you probably know better that climate projections can be existentially depressing. How do you grapple with the emotions that come along with the work that you do?
Great. Okay, this is my FAQs. You know that FAQ thing? This is absolutely my FAQ. Thank you for asking it, because you can see from my personality. So you now have seen me for almost an hour, and you can see that I don't have a pessimistic bone in my body. But seriously, I want to address this because it's so important. Yes, the climate change is the significant planetary challenge of our time and continuing into the future. But because I've been so fortunate to experience all around the world researchers, politicians, national leaders, regional farming groups, all taking on the challenge. I refuse to be pessimistic about climate change. And I want there's like a kind of a, tipping points of, in climate science, we have tipping points of a process that gets going slowly, then all of a sudden it hits a threshold, and then things go rapidly. There are tipping points in solutions, and we are going to get there. We have to keep working on it, keep becoming aware, keep doing our work, working with stakeholders, making the solutions happen. Otherwise, what can we do with pessimism? But I understand, and it is very, very challenging, but we've got to work together to solve climate change.
Thank you. So I'm going to read the last question. To build on Bibanji's question about evolving science, how will generate artificial intelligence change the science of modeling?
Yes. Okay, so this is the latest, as I said, this is the latest group of that has, so AgMIP is like new way of doing science. Groups come together when there's challenges, when there's research challenges, come together from groups all over the world and across, by the way, early, mid, and later career. By the way, the AI, a lot of it is the early career folks leading the way on this. It's so exciting. So what they're doing is they're creating ways to use AI and machine learning, bringing the data sets together. So looking at climate, looking at the crop model results, looking at remote sensing, wearing my NASA hat, and putting all of those in the mix, doing AI analyses on them. So what we can see, we use AI, this is one way we're using it, but I think it's very exciting. It's to identify areas of weakness within the models. No model is perfect, but where do we need to prioritize model development? And and we can do that all over the world, and then pinpoint here we have to work on, for example, high temperature, high stress, or frost events. And then again, this speeding up of where we actually have to work to keep up to step up the pace of response. That's an example of how we do AI and machine learning in AgMIP.
Thank you so
And
much.
join that group. By the way, please join that group. It's absolutely fantastic. And, by the way, join these groups of AgMIP and you get like lots of papers.
Thank you. So we have one hand raised, Janet Lewis from the audience. So would you please? Okay,
Hello.
thank you.
Hello,
Janet.
Dr. Rosenzweig. Thank you so much for doing this today. It's really an honor to have you join this series. Such an honor. Okay, I see that we just got 1 minute, so I'm going to make this as fast as possible. So my background is as a wheat breeder, and I used to breed for a private industry in the Great Plains of the United States. And and moving from Michigan in the United States, so very temperate, much more temperate to much more extreme. And then I was working with Matthew Reynolds, our lead physiologist for Heat and Drought Wheat Improvement Consortium. And now I'm working with the Sustainable Agri-Food Systems with SIGSNAP at CIMMYT. Okay, so to give you that little background. So I was seeing these projections before about the improved performance of wheat into the future. And it concerned me because from my personal experience in the field with breeding and with the literature that I was seeing and the discussions I was having with scientists, this was not what I was expecting. I mean, and so I wanted to hear from you. One of my big concerns is how well these models are taking into account extreme conditions, because I thought, even if we have general trends, the plants just can't survive certain extremes. So I wanted to get your sense of that, because I'm concerned about what kind of investment is going to go towards adaptation with wheat if there's this kind of view that looks like, hey, it's going to be all rosy. So I wanted to basically get your feedback on that. That'd be great.
Yeah, this
Thank
is
you.
absolutely a great question. And guess what? This is what I say to the wheat team all the time. I said, those greens up there in the in the high latitudes, wait a minute, what's really going on? I asked the very same question to them. Let me just say that it's okay. So this is, it's a combination of the C3, CO2 effects. It's a combination. Why are the models showing this? CO2 effects. Also because the temperatures are lower there, as you know, so that when the projections go on, they're still within within the wheat growing windows range, right? However, I really think, and I'd like to hook you up with Cynthia Rosenzweig and Pierre Marthe, who are the leads of the AgMIP wheat team, and by the way, the wheat team there's 8 different groups working on model improvement, and this is one of the questions. So I feel that in terms of extremes, there are high temperature extremes, there are soil stress, there's all those are there. Again, they're not perfect, and this is so critically important for wheat in the future. So Janet really would like to please follow up, and let's follow up, because I've asked them the very same question that you're bringing forward. So thanks very much.
Thank you.
Thank you. So there is one comment on the chat. It says, I remember well that sign in the women's bathroom at ASA that started women in agronomy. So
Who is it?
SIGSNAP, director of the Sustainable Agri-Food Systems Program.
Oh, wow, let's be in touch. That's amazing. And now that it's going every year, and and mentoring, and doing a lot of great things. And we hosted, one of the things we did was host the very first all women symposium, and then we did a book of it. So that's whole professional society. I just want to say also a big shout out to in our case ASA. It's just
Thank you.
great society, so we have to be in touch. Please let me know.
Yeah,
please follow up.
So thank you so much, Cynthia, for your great talk. We very much appreciate you sharing us with with the audience, your professional and personal growth experience and research on climate change impacts, and also for those professional PS tools for building a successful career. So thank you very much for your time. And we thank also the audience for joining today, and invite the audience to the following seminar, Catalyst of Change, Women Leaders in Science, on Tuesday, January the 30th. Thank you very much.
Thank you, everyone. Thank you, Isabel. Thank you, Bram. Thank you to all of you. Thanks. It's great to be in touch. Thanks. See you at CIMMYT in AgMIP 10 next year.
Thank you.
Thank you.
I think we need more investment that really brings farmers to the table in conceptualizing and prioritizing the research so that the research that we're doing is designed to meet farmers' needs. Gets the research sort of out of the lab and into the field. That we've constantly been moving through these big breakthroughs that have really unlocked the potential of agriculture. And I think that we're continuing to do those. I don't want to lose sight of the fact that research is long-term and it's very incremental at the same time. So I think what a breakthrough right now is our ability to integrate across disciplines. You have crop breeding, you have animal science, you have data science. And I think that because we're so connected, and I think there's a really a new philosophy around converging sort of all these different research disciplines together, that could be a breakthrough, is the fact that we can address a problem by bringing different disciplines together. As consumers really start to get an understanding of what goes into their food system and are really asking for and demanding a more sustainable food system, it might be the same hamburger, but it's going to come from cattle that are producing less methane and contributing less to climate change. It might be the same tortilla, but it's come from corn that is much more drought tolerant and farmers can grow it at a greater profit. And so many companies recognize this, that consumers really want a more sustainable food. And the companies have made commitments. They say, you want it, we're going to deliver it. And now the companies are trying to figure out how to deliver that.
Please join our next seminar in the Catalyst of Change series on January 30th.